Hi everyone, welcome to my YouTube channel. I hope you all are doing extremely well. So today in this video we are going to solve first two questions for bi-weekly contest 75 on the LeetCode platform, right? So the first question that you must be having, that was the question minimum bit flips to convert number. So first of all we'll be going through the problem statement, then we'll be having a look on the approach part and the code part as well, right? So let's start with the problem statement. But guys, before proceeding further, if you are new to this channel or if you haven't subscribed my channel till now, then guys do consider subscribing my channel. It will really motivate me to create more such content for you, and I'm sure the channel will be helpful for you. So do subscribe my channel and make sure to join our Telegram community as well. The link for the Telegram channel is in the description itself. So with that, let's get started. So a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. For example, x equal to 7, the binary representation is going to be 1, 1, 1, and if we may choose any bit including any leading zeros not shown and flip it, we can flip the first bit from the right to get 1, 1, 0, flip the second bit from the right to get 1, 0, 1, flip the fifth bit from the right, a leading 0 to get 1, 0, 1, 1, 1, etc. So we have been given two integers, start and goal. We have to turn the minimum number of bit flips to convert start to goal. Right, so you are having two integers, start as well as goal. You have to determine the minimum number of bit flips that will be needed for the conversion of start to goal. For example, here we have 10 as well as 7. Now what is the binary representation of 10? That is 1, 0, 1, 0. And the binary representation of 7 is 0, 1, 1, 1. So you have to convert this to this, right? So they have shown you this step by step. So 1, 0, 1, 0 we have. What we can do is we can convert this one, this 0, this last 0 to 1. So we are having 1, 0, 1, 1. Then what we can do is this 0 again, like this 0 you can convert in 1. So now we are having 1, 1, 1, 1. Now to make it 7, that is 0, 1, 1, 1, what we can do is this 1 now, this is starting 1, we can convert this to 0. So this is how we got the conversion of 10 to 7 in 3 steps. That's why we are getting the output as 3. Here as well the same thing is getting followed for the understanding purpose, that the binary representation, so here you are having start as 3 and goal as 4. So the binary representation of 3 and 4 are 0, 1, 1 and 1, 0, 0. Right, so we have to convert 3 to 4. So 0, 1, 1, first what they have done, this one they have converted to 0, right? And this one they have converted to 0, right? Then we are having 0, 0, 0. What they have done is this 0, the first 0, they have converted it to 1, and now we are having 1, 0, 0. So it can be shown we cannot convert. Okay, so how many number of steps involved here? 3. Now people notice the question carefully. So if we are going to take the XOR, let's say we are having 10 and 7. Let's say we are having 10 and 7. Right? So for 10, what is the binary representation? 1, 0, 1, 0. And for 7, what is the binary representation? 0, 1, 1, 1. So if you are going to do the XOR operation, so how does this XOR work? When both the bits are similar, you will be getting 0 as the output. When both the bits are dissimilar, you will be getting 1 as the output. So 1 XOR 0, you will be having 1. Then for 0 XOR 1, 1. 1 and 1, both the bits are similar, so 0. 0, 1, both the bits are similar, so you will be having what? 1. So, okay, so this is one case. Now the next one we were having 3 and 4. So for 3, what is the representation? 0, 1, 1. And 4, what is the representation? 1, 0, 0. So if you are going to take the XOR of this as well, so what you will be getting? 1, 1, 1. Because for all of them the bits are dissimilar. Hence we will be getting 1, 1, 1. Now what you can notice, for 10 and 7 we were getting the output as 3. For 3 and 4 we were getting the output as 3. Right? So we can say this is what, after doing the XOR of the start as well as the target, the count of 1 that we are having. So here you can see what is the count of 1 here. What is the count? Like the number of bits, that is 1 here. 3, right? And here as well, the number of bits, that is 1. What is the count? 3. And that's what we are getting in the output, right? That's what we are getting. So that's what we have to do. So we have implemented the same thing here. That's the code for the same. That first we have determined the XOR of start as well as goal. So we are having this while loop. So num is storing the XOR of start as well as goal. So num is greater than 0, right? So num is greater than 0. What was the value that we got when doing the XOR of 10 as well as 7? We got 1101, right? So we have to determine the set bits in this particular value, right? We have to determine the set bits in this particular value. Okay. So first we did the, when you will do 1 bitwise AND with 1, you will be getting 1. Then we are reducing our number. We are reducing our number. We are doing the right shift. Now we have 110 bitwise AND with 1. So count value is going to be what? C plus equal to num bitwise AND with 1. So count value, C value is 1. Now when you will do the 0 bitwise AND with 1, you will be getting 0. So 1 plus 0, C will remain as it is. Then we have, then again we are going to do what? We are going to do, so we are going to have 1 1 now, or we can say 3, right? Okay, so 1 1. So 1 bitwise AND with 1, you are going to get 1 itself. So 1 plus 1, you will be having 2. So again right shift. So you will be having 1 now. So 1 bitwise AND with 1, you will be having what? 1 itself. So 2 plus 1, you will be having 3. Right? So C value is going to be 3, and that's what we are returning at the end. Right? So this was our first code. We'll be discussing. Right? So this was our first code. We'll be discussing the next code in the next video. So make sure to stay updated and make sure to subscribe my channel to stay tuned with the upcoming video.